You're good to go, Tim, and Shar, and Vivian.
All right. Thank you, Sean. Good morning, everyone, and welcome to the Identity Special Interest Group on September 7th. Today, we'll be doing some working group status updates and then a presentation from Drummond Reed on trust spreading protocol. So thank you all for coming. As a quick reminder, we are under the Hyperledger community and the Linux Foundation antitrust policy. So that's right there if you'd like to read that. A few announcements before we get going. Looks like there's some IW planning happening. There's a thread in Discord if you'd like to jump in on that. Animo recently announced making Aries framework JavaScript a global framework. If you want to learn more about that, you can find out that here. BC Gov announced a new Hyperledger Aries related code with us program. Deadline to apply is Wednesday, September 13th. So you can find that here. And the ID SIG has a YouTube playlist, including presentations from previous calls, and you can find that here. So if anyone else has a quick announcement, feel free to jump in here. But if not, we will jump into some working group updates. All right. The Hyperledger Indy Contributors Working Group met on the 29th of August. Was anyone able to attend this session?
Yes, and I think the biggest news on the Indy front is that this morning, just before this meeting, we had the second Hyperledger Indy Summit. This was a continuation of the first Hyperledger Indy Summit at the end of June this year. And so Stephen Curran talked about outcomes and realizations from the first summit. There's continued interest and activity around Indy, but we're largely working on independent activities. So the goal was to create an environment for meaningful collaboration amongst all these groups that are using Indy as a utility, but don't have too much interaction. And so this second summit was because we ran out of time last time for the here's what we need to do part. So we talked mainly about actions around technology, marketing, and regulation. On the technology side, talked about a plan for what's next with Indy and ideas for improvements. On the funding side, talked about a funding model based on regular contributions to support Indy development. And then as well, a non-creds in WCC VC data model standard format. So yeah, lots of great conversations. I think it was a good success on that summit this morning.
All right, awesome. Thank you, Shar. Appreciate it. Looks like the Hyperledger Aries working group met just yesterday. Was anyone able to attend this session? All right, looks like they were discussing unqualified DIDs and DIDCOM v2. If you'd like more info, you can of course follow these links. They'll take you right to the page in their more in-depth summary. Bifold users group hasn't met in a little bit. Aries Cloud Agent Python user group. Was anyone able to attend this meeting? Okay, looks like they're discussing a release and some DID peer discussion. I think that hasn't met for a while. Looks like the Aries framework JavaScript met the last day of August here. Was anyone able to attend the Aries framework JavaScript discussion? All right, looks like they had a new release and discussed some OpenID for VCI and SIOP stuff. Versus not for a while. Let's see. Looks like the TOIP governance stack group met on the 24th of August. Was anyone able to attend this session?
Yes, this is Drummond. I was there. We have several very active topics on the governance side. I don't know what depth to go into, but we are. I'll just say at a high level, our first generation, governance framework specifications came out December 2021. we're recognizing now we'll be doing a second generation in conjunction with the maturity of the technical stack, which is we'll talk about later in this call. So it's not going to happen, right away, but it will be an ongoing project over, I'd say, the next 6 months roughly to get to a second generation of those specs and those tools.
All right, very cool. Thank you, Drummond. And then it looks like the technology stack working group met just on the 5th here. Were you at that session as well, or will your presentation kind of cover a lot of this stuff?
Yeah, I'm the co-chair, or one of now 3 co-chairs. We have a new co-chair, Kevin Griffin from Glyph. This joined Daryl O'Donnell and I. And what you see here is all the 6 active, and there's about to be a 7th active task force. The 7th one is going to be on a new DID method called DIDWebS. A safe or secure method of using DIDWeb, which is turning out to be a fairly popular DID method. So I don't want to take the time here to go over. Whoever is putting together these notes is pretty amazing, because I mean there's a whole notes page on a report out from all of these. Maybe it was just copied over, I'm not sure, but in any case, I could find the link for it. All of these task forces are active and cranking along. I'm mostly going to be reporting on the 3rd one down, the Trust Spanning Protocol Task Force. But I'd take the rest of this call to summarize what all the other working groups or task forces are doing.
Fair enough. Well, no, we'll move it along to get to your presentation here. But yeah, if anyone would like more information, click the links. They are copied and pasted, Drummond. So we have yeah, that is how we got all that info in there. So
Cool.
I think I'm sure the DIF DIDCOM user group or working group met. Has anyone attended a session from these? I wasn't able to find anything when I was looking to update the page, but I think they're supposed to meet every week or every other week.
No, they're meeting once a month.
right.
It's so the user group meets 3 times a month, as I understand it, basically 3 weeks user group and then 1 week of working group. I try and attend those. I maybe make it to half of them. And they're, all I can say is that they're moving along nicely. There is a big intersection between where DIDCOM is going and what we're tackling with Trust Spanning Protocol. I'll talk about that more when I present.
All right, awesome. Thank you. And then W3C standard. Doesn't look like there's anything new from them. So yeah, unless there's any other updates, I think we will hand it off to you, Drummond.
All right, I was going to say, although the DID working group is going to have a meeting so next week in Seville, Spain, is W3C TPAC. The DID working group it's been on IATA since we finished 1.0. There will be a meeting there about the charter for the maintenance working group. And they continue to accept DID methods. I think it's over 160 now. And that doesn't yet include DIDWebS, which, as I said, is going to be a new task force at Trust over IP. And the credentials community group is always, they're just constantly doing new stuff. So that's what I can say about what's going on over there. Oh, you don't have the verifiable credentials working group listed. They're getting close to their what's called candidate recommendation stage for BC 2.0. That will also be an in-person meeting in Seville. I'm not going to that. Brent Zundell that works for Jen is co-chairs that. And as I understand it, they're pretty confident they're going to get out a candidate request, a CR, but they were not able to resolve the tension between JSON LD and other formats like JOTS. So it's going to be a very JSON LD centric specification.
All right, good to know. Thanks, Drummond. And I will look up the verifiable credentials working group and see if we can get them added to this list here. Daniel, I see your hand is up. Did you have an additional update?
Just real quickly, NIST, it's a kind of US centric, but NIST SP 800-63 they had a public draft on Rev 4. Dave just today was giving an update on that. They have 3,800 comments. One of them, and the reason why I'm bringing it up here is they were very centralized focused. So what some of the comments, including mine, were, why don't you cover decentralized, like verifiable credentials and MDLs? So they have added that. So when they publish the final version of -4, special publication 863-4, it will include some level of verifiable credentials in that NIST specification. That was it.
All right. No, I appreciate you sharing. Awesome. Well, I think that does bring us to the end of our working group updates for the day. So I'll hand it off to you, Drummond, if you'd like to take it away with your presentation.
You betcha. And my presentation is going to consist of just one web page. What I'm going to do is just walk through and give you a talk track to the blog post that was just published earlier this week on the TrustRIP site. I guess if it's helpful, I can, for those who like to read ahead, I'll just put the link in the chat. There we go. And we call it the mid-year progress report because when we formed the Trust Spanning Protocol Task Force at TrustRIP, actually, I guess to give you a little bit of this background, I'll pop open quickly this one in a different window and give you a little background. So when we started the work, this task force, we wrote this blog post, as you can see, in January, first week of January. And we started out providing this context that in the development of the TrustRIP stack at TrustRIP, and most folks may be generally aware of this, but for anyone who's new to this whole thing, we knew we were playing, quote, the long game, that it was going to take us a while to design a protocol stack to really tackle the problem of decentralized digital trust infrastructure in a highly interoperable way. And when we say highly interoperable, we're talking about interoperable like the internet's interoperable. It works everywhere. It's as seamless as it can get. It's a huge task. So we developed this diagram, which is in our technical architecture spec, and we have a page on the website that's devoted to the evolution of the TrustRIP stack. And we said, hey, first, we got to tackle, design principles based on the core, 4-level model. Then we have to develop a technical architecture. Then we can finally concentrate on any component specifications that don't already exist. Things like DIDs, decentralized identifiers, or verifiable credentials. We don't have to invent those. They're already there, but there are other components that will be needed. We're only going to do at TrustRIP what no one else is tackling. A lot of what is being tackling, a lot of the other components are coming from DIF or from Hyperledger, things like the Anon creds, as well as, of course, other standards bodies like W3C or ISO IETF. So hang on just a second. I need to, my boss just sent me a text and I said, yes, I just need to answer this. Oh, it's actually better for me. Just quickly. So, what we wanted to establish in January was we have completed what we call the design principles for the TrustRIP stack. And since I have macros on all these, I will take advantage. I mentioned them. Stack. There is the link to that. And the next one I'm going to mention is called our technical architecture spec. Let's see. Yes. No, that is the page we have on our website that actually has a link to both the PDF and the markdown version of the technical architecture spec. So this effort here took about 9 months and during 2021. This one took a good part of last year. But by last fall, IAW last fall, we said, okay, we've got a technical architecture spec. It's pretty mature. It's been in public review. We're still going to make some minor revisions. We decided we would want to tackle a few of the component specs to provide feedback on that. So, but we're pretty happy with the first 2 stages. So what that laid the ground for is to say, all right, what component specifications in the stack need to be done that no one else is doing, and we've identified 2 of them. One is work on trust registries, which we've been working on since the Good Health Pass work in spring of 2021, and the other one is the core of the stack, which is the trust spanning protocol. So we wrote this to announce the start of the work on the trust spanning protocol. And why is it called the trust spanning protocol? Because the model that the internet pioneered, turns out it's not the first hourglass model, but it's just the largest and most successful, has been extensively studied. Why did the internet succeed versus other architectures for a global network? And this is a simple rendering of what the hourglass model looks like for the internet. And the core of it is the idea of a spanning protocol. A spanning protocol is the one common protocol that is supported by all the protocols below it and supports all the protocols above it. But that's what gives you the global interoperability. Everyone can use the internet, even if they're using, email on top of it, using one transport, and HTTP is different, RTP, all that stuff. So that's the whole idea of an hourglass model and a spanning protocol at the center. The whole reason for being of the Trust over IP Foundation is to say, we need to apply that same model to the problem of interoperable trust, not just sharing data across domains, but establishing trust across domains, any 2 domains, anywhere, just like the internet. And we said we need to apply the same. It's in the design principles. The whole point of the hourglass model is one of the 17 design principles, and that means we need the proper support, but we need this protocol right at the center, the trust spanning protocol, and that will support a whole family of trust task protocols that then support applications. And so that's the overall rationale. We had this is a diagram from the more detailed diagram from the technical architecture spec that sort of breaks this out and says, hey, at layer 1, you have to do, an endpoint that's going to speak trust over IP and use it for interoperability. That endpoint's going to have to support whether it's a mobile phone or a tablet, a laptop, a server, IoT device. If it's going to speak this protocol, it's going to have some form of trusted computing, whether it's a secure enclave or HSM or whatever it is, because it's going to have to do cryptographic operations. It's going to need secure storage for what it's going to keep on that endpoint. And it's going to have to use transport protocols to move around. The trust spanning protocol is bound to a transport protocol. The default one is, of course, going to be TCP/IP via one or more of the other protocols like HTTP or HTTPS, or QUIC or whatever. But the whole point is it is transport independent. It can be bound to any transport protocol. And they're really good use cases, especially offline use for using other things besides TCP/IP. So even though we're called trust over IP, trust spanning protocols actually transport independent. And this protocol lays the groundwork for all kinds. As I said, we've got much larger lists, but this just gives you a sense. And I want to emphasize, even though over at Hyperledger and the current state of the industry, we're very focused on credential exchange, verifiable credentials, digital credentials, whatever you want to call them, and the whole trust triangle of issue, hold, and verify. That is fantastic, super cool. It's only one use of the trust over IP stack. Second thing, digital wallets are there's a whole nother class, of course, digital wallets that are all about payment, especially, Web3, cryptocurrency exchange, but those are maturing and adding additional forms of payment. We absolutely believe both of those are going to be covered. But secure messaging, right? DIDCOM, that I think many folks are familiar with, Deep in Aries projects. all the things you can build on top of DIDCOM and DIDCOM protocols belong at our trust task layer. And it's important to point out, it's not just messaging. Streaming data can also use the stack. We're designing it for that. So you want your secure decentralized Netflix, that's something else. So there are many examples of what can be used up here. I'll get to a couple more specific ones when we get to the spanning protocol, but all of those, the whole idea is these trust task protocols now can be called by applications, and the developers of those applications, not only do they not need to worry about how authenticity and confidentiality and correlation privacy are handled at this layer, they have all of the power of one of these trust task protocols that they can just plug into an application. It will make building trusted applications just, I mean, enormously easier. I sometimes, I'm not a developer myself, but I compare it to what some of the UX frameworks do. They just handle so much of the job, so the developer can focus just on what they actually need to do. That's unique for their application. So anyway, I went back to this one to just say this, we have a whole set of requirements in the technical architecture spec for layer 2, the trust spanning layer. I'm not going to go through them here, but as you can see, there are 18 of them. And the whole starting point, I'm going to talk more about this in a minute, is what we called in the spec trust over IP identifiers. We're actually going to change that to just talk about these verifiable identifiers. I'll cover that in a minute. Anyway, so we just basically said, hey, and by the way, this trust spanning protocol, because it does connect, it uses, what we all recognize as DIDs. We're generalizing that to verifiable identifiers, or VIDs. There are 3 protocols out there today that are all designed with that same architecture. That it's obviously DIDCOM is named because it's DID to DID. A lot of folks may be familiar with Carry and Caesar is also, it's actually, you can think of it as a very specialized kind of DID called an AID, autonomic identifier. That's all what the Carry stack is about. And then another diff project, Decentralized Web Node, also is based on DID to DID communications. So there are 3, protocols out there, and all of them are sort of stacks. They're all what we call forerunners to what we're trying to do with a trust spanning protocol. And then we just said, okay, so, and there's a bunch of other protocols out there that today are filling little niches in the stack because there isn't anything that is comprehensive and complete. And if we're wondering why is interoperability so hard in the world of, call it decentralized identity or SSI or verifiable credentials today, it's because of this. It's because of all these options that folks have to choose from. To be very specific, if you're the European Union and you want EIDAS 2 to work, you're going to have to make choices from among the things that are already there that are reasonably mature enough. And we recognize that. We can't do anything about that other than to stick at Trust over IP, stick to our knitting and say, this isn't really going to work for interoperability at internet scale, right? We're not going to get there by continuing to use, and I don't want to cast aspersions on any particular protocols out there. They're all doing the best they can to solve the problem today. What we're tackling with the trust spanning protocol is to say, all right, let's really solve the problem at a very, very wide level. And that's the introduction to why we established a trust spanning protocol task force, which, as I said, kicked off in late January. Now, move forward. I'm going to stop there for a second. If there are any questions about, I guess I never turned my video on. Happy to do that. Any questions before I then dive into?
I have a question.
Go ahead.
Drummond, if you look at the initial Hourglass model, which is the IP model,
Yes.
everything below it is shown as basically, I mean, not in this particular diagram. Yeah, so most of them, well, the layered model you already have, But the layer just below the IP is basically all different kinds of protocols that allow communication and create local area networks.
Yes.
So in other words, it's translating those into a standard canonical form, and the IP protocol, and then everything just links to that IP protocol,
Yeah.
Internet Protocol. But in your diagram, there is a whole bunch of things that are a mishmash of different kinds of technology there, meaning the storage layer is not the same as some other thing. So there might be a paradigm mismatch here, but I'm willing to accept that. But that complicates matters quite a bit for your trust spanning protocol.
I would agree. I think if we're talking about this diagram,
Yes.
and you see here at layer 1 where we're talking about trust support, if we're talking about strictly a protocol stack, then the only thing at layer 1 that matters is that you have whatever the necessary transport protocol that you're going to be using for the trust spanning protocol.
Because the only thing the trust spanning protocol should know about are those network transport protocols, as long as they can support the capabilities that are the trusted computing services and the secure storage services.
Yeah,
that would be a fine thing. But if you start mixing and matching layers, then I don't know. I mean, maybe there's a reason why you do that, but
so Vipin, are you saying that of these 3 boxes down here, these other 2 don't really belong here because from a protocol stack standpoint, it's really just the network transport protocols that are unique?
And then those others should be below that, because those have to be supported using
yes,
the transport protocols, because
yes,
otherwise, transport protocol is the only thing that you're going to connect to in a certain sense. Yes.
Yep.
You're saying that those transport protocols have to support those basic capabilities that you're talking about, which you just started out by talking about the IDs, but then
yes,
there are the channel stuff and everything else, but everything has to come through those network transport protocols.
I 100% agree with you. In fact, we just had a good conversation yesterday on 2 different Trust European meetings. We are revising. This diagram is definitely out of date at this point. Again, it's in the current version of the technical architecture spec, but we knew, and we even put in the current public review draft, that we know this diagram needed to evolve. It's going to evolve, and you're absolutely right.
Thanks. I think you should continue, because this can go down a rabbit hole.
Sure.
Which probably nobody else wants to talk about.
Exactly.
But I'm just bringing that, bubbling that to the front.
Yep. No, it is a very good point, and so that no one is confused. In terms of a protocol stack, from the Hourglass standpoint, it is these network transfer protocols that the trust spanning protocol runs over. So I don't have that diagram right here, but it ends up being an hourglass on top of an hourglass, what sometimes called the waist and the neck model. And the lower hourglass, when you're building on top of TCP/IP, is the TCP/IP stack. So that's how it stacks up together. All right, so now I'll switch over to our progress report, and I'll just go down through, and I'll touch on there's 7, what we cover 7 pillars of the design that we've worked out over the first 7 months of this year. And we published this blog post because we want to basically just not go silent until we're all done. We wanted to document the milestones we're going through as a task force. And we were particularly excited because, as we cover here, we actually identified for various reasons. We created a actually it's useful enough. I might just bring it over here right now and show you. No, that's right. I'll skip that. There are basically 10 stages that our working groups and task forces go through in preparing things, and the proposal stage is in many ways one of the most exciting, which is, okay, we've outlined the problem, we know what the sort of the scope and the constraints are. Now, how do you solve it? And we spent 3 months going through that stage and had 4 sort of complete proposals as to how to solve the problem from these 4 gentlemen you see listed here. And so once we had that, then we entered what we call the consolidation stage. And that's the hardest part. Can you take the proposals and figure out and bring them together into, you know, one overall coherent design? And sometimes you can't do it and you can't solve the problem, or you can't be successful. And believe me, we had to have a lot of long, in-depth discussions, you know, as you hash that out. What I was particularly excited about is that it did come together in a way where Mr. Herman is no longer active, but where everyone else said, hey, this really is, you know, we're excited. We think this is going to work. It's a combination of the ideas that were brought from those proposals and the other task force members. It boils down to these 7, what we just call pillars of the design. They're all different aspects, and I'm just going to cover them fairly quickly as soon as I take a sip of water. Sorry, I've been talking since 6:30 this morning. So I will just quickly step through them. You can see all 7 listed here, and I'll just step through, and stop me at any point if you have a question about a particular one. I just want to sort of hit the main points. The starting point is really easy. As I said, we've decided the term we want to just standardize on the term verifiable identifiers, because that diagram I showed you earlier, obviously the one that has had the most attention is DIDs, and they are decentralized verifiable identifiers. The reason for this term is that we did not want to exclude identifiers used on the web today that are cryptographically verifiable, like HTTP addresses, URLs. The challenge from a security standpoint is there are several well-known holes in terms of relying on DNS, and I'm not throwing shade at the SSL or TLS protocols. You know, pretty good stuff, but they don't provide the same characteristics out of the box as DIDs, where you can rotate keys and you can rotate endpoints, network endpoints, and maintain continuity of a relationship. There are ways to address those, and those end up being DID methods like DIDWeb or DIDWebS, and there are other ways to do it. So we wanted to say, hey, we're just going to talk about any form of verifiable identifier. On the other end, there is a subset of, you call it DID methods, or the carrier community calls them AIDs, autonomous identifiers, that are even more secure and more decentralized, and have more capabilities than non-AID methods. So we're just lumping them all together and saying our starting point is verifiable identifiers. And you can see the 3 key things that any verifiable identifier needs to be able to do. You can resolve the current public keys, cryptographically verify that they are valid. You can obtain the current network endpoints for speaking this protocol, for establishing a TOIP connection. And the identifier does not need to change when the keys or the endpoints are rotated or updated. That's the essence. That's our starting point. Now, we've also, because there's such a variation in the kind of identifier and the strength of that identifier, we've identified that we also need to design what we call an appraisability framework, a way that you can, a machine, ideally, maybe in combination with a human, can actually, when presented with a particular VID, get and verify a description of that, so they can make a trust decision. Do I trust the underlying infrastructure, the governance framework that's associated with whatever? There's a surprising number of factors that go into making that decision about whether you trust that VID and what it's based on. So anyway, that's all I think I want to say about that, because as we say here in this paragraph, all the VID-based protocols also rely, when you need to initially form a connection, you got to have some way of discovering and verifying the VID of the other party, what we often call a public VID if you're exchanging it publicly, or if you're even if you're doing it like phone to phone. And that, of course, can be QR codes. It can be a bunch of other ways. Those methods, UBIs, we call them, are just part of what you need to do. So that's pillar number one. It all starts with verifiable identifiers. Pillar number two, end-to-end authenticity and confidentiality. We all know, we all hear about, hey, you know, WhatsApp, Facebook Messenger, iMessage, Telegram, Signal, they're all end-to-end encrypted. That's wonderful. That is confidentiality. They also do address, okay, do I know this is really from, you know, the other endpoint? That's the authenticity part about it. I was not aware that the combination of what you need for signing and encryption, that there are a bunch of different ways to put those two together. And a bunch of cryptographers have argued for a long time about what is actually the most secure way to do it. And we refer here, and I learned all about this, that the pattern that actually results in the greatest the greatest security, the hardest to break in any way, is called ESSR, encrypt sender's key and sign receiver's key. You know, follow up on the links, dive deeper into it. But the task force, once we got educated on that, we just said, we need to apply that pattern to every to all the protocols and channels in the overall design, and we have 100% consensus on that. So I'm just going to refer to that ESSR pattern is used in every one of these channels that we're going to talk about. So pillar number three, and this is the first one. I've got a nice little diagram to go with. There it is. Direct connections. So if you have, again, you've got verifiable identifiers, so you can sign and encrypt every message. You can deal with authenticity and confidentiality requirements for any trustworthy connection. The third area is what we call correlation privacy. If you're going to share data that in the end the other party can decrypt and they've got the data, then the usage privacy of that data is not something you can control with technology. You can do it with governance, you can do it with contracts, you can do it with other non-technological means. The other part, though, is correlation privacy, often called, you know, the metadata observability. If you can see everything that's going on in the network, you can learn an awful lot, even though you can't decrypt the messages. And so what can we do technologically about correlation privacy? And there are two steps. And the first one is remarkably simple. It's shown in this diagram here. You can have a public channel between two vids that are publicly observable, like over the internet, if you've got a publicly observable network. But what you can do is then you can tunnel another channel inside of that with two vids that are not publicly observable. So A1 and B1 are only known to A and B, and you can't see those over the network. Now, you're going, well, I know A0 and B0, and I know they're talking to each other. You're absolutely right. However, one thing that A0 and B0 can do there is turn around and say, all right, if we want to change our public channel, change our publicly observable identifiers, we can do that and not have to change A1 and B1 because they're hidden and they can stay hidden. And so it's one simple way you can, it's one step towards correlation privacy. It's not a complete solution, but it turns out this pattern, as you'll see, is actually very useful in a number of other ways. So we call this just very simply the inner channel and the outer channel. So that's our third pillar. And I got about 17 minutes left, so we're making good progress here. Now, if you want full correlation privacy, it turns out what you need to do is nest one level further. And I won't take a bunch of time, you can read through this, but the basic idea is you need to add one or more intermediaries. This one shows two, but you can have, the more intermediaries you add, you get both scalability, and the idea is no intermediary actually knows the full path. The only ones knowing the full path between A1 and B1 are A and B. And actually all they need to know is their intermediaries. It could go through other intermediaries, and the intermediaries can connect just like routers do today, but none of them know the full path. What they do have is connections with each other. That's the outer, that's the red. And then what they're running between, they're putting the inner channel through, the blue is a routing protocol. So it's 3 layers of nesting. A1 and B1 have the direct connection that no one else knows about, their identifiers and this this path. Each of the A1 has a connection with its intermediary. You think of it like, if you use an email server style analogy. And over that publicly observable connection, you have this routing protocol. So you know that this is A's intermediary, but you don't know who A is talking to. You don't even know the other intermediaries that you can come and say, well, there's a connection between these 2 intermediaries. I can publicly observe that, but you don't know which of the endpoints are using that connection. And again, neither of these intermediaries knows the full path. So this is you look at it, you go, it's sort of like what onion routing accomplishes, but it's simpler. And it it doesn't require all the infrastructure of unrouting. It does require intermediaries that know how to speak this routing protocol. And that's going to be a requirement of broadly deployed trustworthy infrastructure. All right, take a breath at each one of these to see. But I might as well plow through, and then we'll see if there are any more questions. So that's number 4. Now, number 5. Once we've established this channel infrastructure, this is where it really gets pretty cool in terms of now we're getting into capabilities of the spanning layer and what you can do with it to set up for trust tasks. And this one is, once we've got these nesting of channels, and you've got this default channel A1 and B1 will always have between them, they can now use that channel as a control channel to set up other channels as needed for as many different, what we call relationship contexts, as those 2 parties. And don't think just person to person, think person to business, person to device, device to device, business to business, whatever it is, right? And these relationship context channels, there's all kinds of uses for them. I think we listed up here, you can instantiate a new channel to add a new set of parameters for stepping up identity assurance, right? Authentication. Hey, you want to now use a high value payment. Okay, we're going to establish a channel that requires a liveness detection or a certain set of a trust task, like verifiable credential exchange has to take place. You want to have a group messaging channel or institute something like MLS for group messaging. You want to have a streaming channel. You want to instantiate. You want to switch to a different pair of vids for a particular transaction that, again, are only one-time use. So you keep that. You want to present private. There are all kinds of any particular trust task at layer 3 might say, hey, I would need to instantiate a new channel with these parameters, and you can use the control channel to do that, and you don't need any other infrastructure to do that. So that's number 5. Now, the last 2 are fairly easy to explain. Any protocol has to turn around and say, what's the encoding? How do we do it? This is an incredibly contentious topic when it comes to cryptographic protocols. They're very heavyweight with cryptographic data structures, signatures, and hashes, and commitments, and all that. And I don't know if we're ever going to agree who wants to use JSON, who wants to use CBOR, who wants to use message pack. Do you want it text? Do you want it binary? Caesar is one of the specifications in the Carry family. It's now in the AC/DC task force at Trust over IP. Caesar was developed to tackle this problem and say, hey, we can have encoding that's optimized for cryptography that can carry JSON, CBOR, or message pack, and it can exchange the data in either text or binary or a combination in the same message or stream. It's also designed for pipelining. Again, I'm not an expert down at that level, but I've watched architect after architect be very skeptical about, oh, last thing we need is another, serialization and coding format, and then come out the other end with enough experience to go, oh wow, I don't know how we're going to do it without this. So we also got the consensus about using Caesar, even though it's fairly new. And the last thing I'll cover, and we'll have a good 10 minutes here for questions, is once we have all those other pillars, what we need at layer 2 is just the framework for trust hash protocols that they go above. And that's the thing we least have to invent, because DIDCOM, Carry, and DWN all have established those frameworks. They're all designed with the same basic idea. Hey, we get the base protocol, and now you can build what Trust RP calls trust hash protocols on top of that. And they all follow the same basic thing. You have a protocol identifier, which of course could be a VID, and that defines the message family. That's what DIDCOM, or at least used to call it. I'm not sure what they call it now. And in that family, you have to have definitions of the packets or messages in each one, and then of course the protocol logic, business logic of the protocol. We don't need to reinvent any of that. Section 9 of the DIDCOM V2 spec is a perfect example. We also agree, and the DIDCOM folks that are participating have pointed out there's some handful of standardized trust tasks that we also want. They probably will be separate specs, but that we think need to be defined to use with the trust spanning layer. Just like, the easiest one to example is just like we use ping, the very simple ping protocol with TCP/IP just to check a connection, and they call it trust ping, and it makes a lot of sense. So anyway, that framework is then what will set up the ability to define standardized, whether they're narrowly designed or broadly designed, very horizontal or very vertical, it doesn't matter. All the trust tasks that we need. We provide a small example. I'm going to point out, I guess, actually, no, I won't take time. We have finally developed a list we're adding to the technology architecture spec of 27 what we call canonical use cases for the trust RIP stack. And we wanted to do it not to say you can do, they're just examples, but we wanted a bunch of examples that were not just verifiable credential exchange. I think of those 27, I think 7 of them are verifiable credential exchange, and there's a bunch of others. And so this is a little overview. And that's it. We are now in the working draft stage. We just had our first meeting, first step on the working draft yesterday. We meet Wednesdays, 2 meetings, 8 a.m. Pacific and 6 p.m. Pacific for the 2 time zones. And if anyone's interested, we'd love to have you. And with that, I think there's about 10 minutes left for questions.
Question. Okay.
Go ahead, Brad.
So with regards to IoT, I saw that in the at the beginning.
Yep.
Is there a focus on that with regards to what is being presented here?
The answer I'm going to give you is the trust over IP architecture is designed very much like the internet to connect any two entities, and I mean that in the very, you know, in the very precise term of entity, that need to have a trusted connection, engage in some kind of trusted interaction. So we don't distinguish whether that entity, the communicating entity is a person, it's an organization, it's a IoT device, it's a AI, a bot, it's whatever, right? We absolutely have said from the outset that the protocol must be designed so it can be used by, you know, the thinnest IoT device or sensor that can actually handle cryptographic operations, because that's the only way we can secure that endpoint. But as long as it can do that, it's absolutely, and one of my co-leads, my two co-leads of the task force are Wenjing Chu from FutureWay, and Sam Smith from Digital Trust Ventures and you know, the Carry Stack. Sam is a huge IoT guy, and everything, like even Caesar is designed so it can support, you know, the thinnest IoT device that can do cryptography, is the way I would put it. So I won't say it's a special focus, but it's absolutely a requirement that we're not designing something that, you know, could not be used for IoT.
And so that architecture, is that available, or are we still?
Well, so where we are, as I said, the specs you can look at now, you can look at the design principles, you can look at the technical architecture spec. You can't implement any of those. They are, you know, design principles, and then the technical architecture is requirements that the component specs have to do. The two component specs we're working on at Trust over IP are this one for the trust spanning protocol, which, as you can see, is going to end up being a little suite.
Okay.
And then one of the trust task protocols is a trust registry protocol. How do you talk to a trust registry? And there's a separate task force that meets Thursdays, 2 meetings every week. They just had their meeting in the last hour. And that's going in parallel with our work on this. Our goal is to have, you know, specs. Well, we want to basically complete the specs this fall together with implementations. We want to have implementations of both. I know the trust spanning protocol, the initial implementation will be in Rust. It will probably be at contributed to Open Wallet Foundation, but you know, collaborate the same sort of collaboration.
How can you send me the link so I can put my email so I can get notifications?
Yeah, well, sure. I tell you what, let me put my email address. Maybe the easiest thing is the
Okay.
well, the easiest thing, are you a member of Trust over IP? Because that's the easiest thing to do. If you join Trust over IP, then you can pick the mailing list you want to be on and groups you want to be notified by. And that's just right on the Trust over IP website, which I can put in chat.
Oh, the trust type. Oh.
Yeah.
I was on my phone and then I came on here, so I lost the ability to grab that link. Thank you.
No problem. Yeah, it's right there. Just contact page. I don't have. Do I have Judith? I think it's at ip.org. You can also just email Judith. She's our executive director, and she can set you up with that right away.
Okay, thank you.
Any other questions that I can answer?
Raman.
Yeah.
For the channels that you talked about, what metadata can be observed even after wrapping them?
The whole idea of VIPN is the only thing that can be
not that
observed.
one. I mean, you know, the earlier one. This is the control versus others, right?
Yes, exactly. So you're talking about going all the way back to that one?
Yeah, because that is the basis of all the rest of the channel wrapping stuff, right?
Yes. So the idea is what you can observe publicly, like assuming this is like TCP/IP, you're using a TCP/IP transport. So it's the internet you're observing. You'll be able to see A0 and B0 and that there is traffic going between them.
Can you gauge the level of traffic? Can you look at get any other piece of metadata?
We have been discussing that. One thing that can you do traffic analysis yes, as you can do it on any protocol, but it does, and we're going to discuss there. Basically, if you want to defeat things like traffic analysis, then what you do is you start sending messages that are
Yes,
Uh,
fake messages
yes,
or
noise.
padding or whatever, you start
Exactly.
doing all kinds of crazy things like drop this message, it's only to spoof. I mean, it's only to help defeat traffic analysis. The other protocol that comes to mind is Dandelion in Lightning, which for the next few, like for example, when you have intermediaries, that's when that's the context in which Dandelion operates.
Yeah.
And there's some usefulness in looking at that. I mean, I know that you already said you looked at the onion stuff.
Yeah.
But this is, this is a different problem being solved in Lightning. Again, it is to obscure the path and
Yep.
the level of messages being sent. But back to the original comment, which is, sometimes I get the feeling that you're stuffing in too many things into the trust spanning protocol. If, all these things have to be supported by the underlying transport layers that you're supporting, then you can do this. But if not, you cannot, right? I mean,
Well, I think just to make sure I'm being clear, in classic layering, the transport protocols don't have to know anything about what will happen is trust over IP. The trust spanning protocol will just be, from the standpoint of the TCP/IP stack, another protocol above the IP layer, right? And
Yeah.
in fact, we're looking closely at binding to UDP for various reasons. I mean, you can bind to either one, but UDP has certain advantages that,
yes,
yeah. So,
it's a
so we have to have the
broadcast
bindings.
protocol too.
Yeah, exactly. And so, we basically want to keep the trust spanning protocol as light as we possibly can to cover authenticity, confidentiality, and correlation privacy. And if we can do those things, then the trust hats protocols don't have to worry about any of those. They can concentrate on just what they need to add, and we'll get a really nice stack.
Beautiful.
No one said it was easy, and if it was, it wouldn't
No,
be taking
no,
us.
I know.
But anyway, this is where we are at with the design. And will you be at IW, Vipin?
No, I'm hunkering down in New York City.
That's a good place to be doing it, though.
Well, anyway, so I will follow and contribute as needed, because what's happening with me is that I have experience actually coding many of these things. Sorry, this is New York City after all.
Yes.
Anyway, time has come and gone, but yeah, so basically I have experience with the actual development in protocol development, and also in binary and text format, streaming and at rest, and cryptography, of course. But we'll see. I'll try to engage.
Okay, sounds good. All right, I know we're over time, so
Yeah, we
Well,
really
after-
appreciate you joining, Droven. Appreciate the great session. So thank you all for your time, and we'll close the meeting out. Have a good one.
Thank you so much, Drummond.
thank you all. We'll see you
Thanks.
at the next meeting, if not IAW. You bet. Bye-bye
Thank
all.
you very much.
you.
Also from Helsinki.
Oh, thanks, Bo. Good to talk to you. You bet.
See you.
Talk
Still
soon.
going very strong you are, and thank you very much.
Good. Well, we want to solve the problem, you know. Excellent. Talk to everyone soon. Bye-bye.
Thank you.
Thank you.
Bye.